Manage with the blade to the sugar. This is like
what do we call? Let me draw water molecule. This is water. What bond is holding the hydrogen and the oxygen in the water molecule? What I mean, how many type of bond have we studied so far? Three. What are they? Metallic, covalent, ionic. From those three, which type do we have here? It is covalent bond. When you boil water, the steam, is it still H2O or is it hydrogen and oxygen? It is still H2O. Did I break the covalent bond in water molecule? What did I break? The intermolecular forces, the bond between the molecules. So covalent, ionic, and metallic, they are intramolecular forces. They are forces inside the molecule. But intermolecular forces are forces between the molecules. Which one are stronger, the inter or the intra? The intra. Boiling water breaks the inter, it did not break the intra. So, the next slide you need to know. Listen carefully. Those are the intermolecular forces you need to know. One is called London dispersion or just dispersion. Another type is called dipole-dipole. Another type is called hydrogen bonding. Another type is called ion dipoles. I am going to tell you the difference between each one of them. Okay, listen carefully. Dispersion or London dispersion or induced dipole, those are the weakest intermolecular forces. They are forces between non-polar molecules. Even though all the others also include that weak force. The London dispersion exists in all the others, but non-polar molecules have only London dispersion. Second type, dipole-dipole. They exist between polar molecules. Dipole-dipole between polar molecules. So the dipole-dipole polar molecules have dipole-dipole and London dispersion. Hydrogen bonding is a special type of dipole-dipole. It is a stronger version of dipole-dipole. It exists only between hydrogen and fluorine, oxygen, and nitrogen. Remember a kindergartner that cannot spell fun. Fun. F-O-N. Okay, hydrogen bonding exists between hydrogen and fluorine, oxygen, and nitrogen. Okay, they are in line, one line on the periodic table, F-O-N. When those are bonded with hydrogen and they have the intermolecular force between them, then you have a hydrogen bonding. Hydrogen bonding is stronger than the other types of dipole-dipole, and hydrogen bonding has dipole-dipole and London dispersion force between two polar molecules. The fourth type is ion dipole. It's between an ion and a polar molecule. Just think if you dissolve salt in water, the NaCl will dissociate into Na plus and Cl minus. So the force between that Na plus and the water will be iron dipole. The force between the Cl minus and the water will be iron dipole. Let me go back and show you the case for each one of them. Okay, this is your HCl, the bond between the Cl and the H from one molecule to another. This is dipole-dipole. Yes, because HCl is polar. HCl is polar. That force between those two polar molecules is called dipole-dipole. But it also includes London dispersion. Here is a case for iron dipole. You have a positive ion, and then you have a polar molecule. You have a negative ion, and you have a polar molecule. So the negative side of the polar molecule will be attracted to that cation. The positive side of that ion will be attracted to the negative, the anion. Here's an example. This is water molecule. This is another water molecule. Here's a force between oxygen in one water molecule and the hydrogen from the other one. This is oxygen and hydrogen. But inside the molecule, you should have those also, the oxygen, the fluorine, and the nitrogen. One of them. This is ammonia. Okay? So the hydrogen of one ammonia is attracted to the nitrogen of the other one. This is hydrogen bonding. Okay, so you need to have hydrogen and one of those three to call it hydrogen bonding. That hydrogen bonding has dipole-dipole and London dispersion in it. Yes. This is an example of London dispersion, the weakest force, but that exists in all the others. When you have a non-polar molecule, there should be no attraction between them. Okay, but in occasion, some of the ions on one atom can go on one side of the atom and get attracted by the protons of the other one. So this is a weak attraction between them. London dispersion or dispersion or induced dipole, those are the weakest force. All right, instantaneous dipole, another name, another term for it. Instantaneous, just happened for a fraction of seconds. Instantaneous. Induced dipole. All right, I would strongly advise you to take notes or you watch it over and over. There are 4 types of crystalline solids. 4 types. Molecular. They are formed between molecules, usually soft with low melting point and poor conductivity. Molecular. Another type is covalent network. This is really a special type of solid. This one, covalent network. Very hard. It has very high melting point. Poor conductivity. And there are specific examples of those. Those examples, they are some carbide, like your diamond. Okay, silicon dioxide, which is the same as sand. There are special examples of a covalent network. Silicon carbide. Ionic, okay, formed from ions. They are hard, brittle, high melting point, and poor conductivity. So they will conduct only when you dissolve them in water or when you melt them. They do not conduct electricity in a solid state. Metallic form from metals. They are from soft to hard. You know the metals from group 1, they are soft. You can cut a piece of sodium with a knife. All right, and soft to hard, high melting point, good conductivity. They conduct in a solid state and they are malleable and ductile. Question.